So we're in your geometry and we're on chapter 6. It starts off with proving polygons regular. So what's a regular polygon? We have a definition. A regular polygon is a polygon which is both equal angular and equilateral. So it has to be both. So if you have a test question that says just equilateral or just equal angular, because you can have an equilateral one that doesn't have equal angles and it won't be a regular polygon. So that's important. So on to theorem 76. It says an equilateral polygon inscribed in a circle is regular. So here we have a polygon and it's inscribed in a circle. That means inside the circle, inscribed. Let's see how it's inscribed in the circle. It's going to be regular. So that's that definition there. On to theorem 77. It says, if a circle is divided into any number of equal parts, the chords joining the successive points of division form a regular polygon inscribed in a circle. So if a circle is divided, number one, the chords joining the successive points of division form a regular polygon, like this. Then the tangents drawn at the points of division form a regular polygon circumscribed. So here's the tangents outside. So basically they're saying inscribed is going to be inside the circle. So here's the circle, and this polygon is inside the circle. Well, another polygon will be, see how this is like this pentagon here, or what's it, 1, 2, 3, 4, 5, right, in the midst, 1, 2, 3, 4, 5. Here, this house figure is inside the circle, and then you have it outside the circle, and these are both regular, okay? Just a definition to know. So on to corollary 77.1 says, if the midpoints of the arcs subtended by the sides of a regular inscribed polygon are joined to the adjacent vertices, then a regular inscribed polygon of double the number of sides is formed. Basically, all this is saying, if you take the midpoints and put the midpoints between these and you divide it up, you're going to have double it. So taking all the midpoints. So this is a corollary to what we just saw. So if you took this here and you put the midpoints in the midst, then you're going to, the midpoints have a regular that's double the sides, right? Double number of the sides. So, and if tangents are drawn to the midpoints, again, if the tangents, put midpoints on those tangents there, you're going to have a regular circumscribed on the outside. Circumscribed means on the outside of a circle. And then a regular circumscribed polygon of double the number. So it's basically saying if you take all of the midpoints here too, you're going to have a double on the outside is circumscribed. On the inside, it's going to be inscribed. But if you do the midpoints, you're going to have double. Of course, you're dividing it into double, right? So another one here, let's see. Well, okay, I'm not going to go over those exercises because we're going to go over some of those when we do the quiz. So here's section 2. Circumscribing circles about and inscribing circles in a regular polygon. Okay, going on to theorem 78. Theorem 77 makes it possible to construct geometrically an inscribed or circumscribed regular polygon on n sides when 360 degrees over n is an angle that can be constructed with a ruler and a compass. In cases where 360 over n is an angle which cannot be constructed geometrically, the protractor may be used. Anyway, this is just a little introduction here, because as if we're going to construct them. But let's go into theorem 76. It says a circle may be circumscribed about any regular polygon, and a circle may be inscribed it. Just had that. Basically, if you have a polygon that's regular, you can put a circle around it, or you could put a circle inside it, right? May be circumscribed about any regular polygon, and a circle may be inscribed in it too. So if you have a regular polygon, you're going to be able to circle it very easily. So on to this corollary here. Corollary 78.1 says, in any regular polygon of n sides, number A, the angle at the center equals 360 degrees divided by n. Why do we say 360 degrees? Because that's the circle. That's the degrees of a circle, 360 degrees divided by n. And any angle of the polygon equals, any angle is going to be n minus 2 times 180 over n. So you need to know this formula if you write it down, because you're going to have questions there and you're going to have to figure this out. Probably questions on the test. So if you have a side, any side, it says basically the angle at the center equals 360 of an n. If you want to find the side, you're going to divide that there and you'll be able to find the side. N is going to be the side. So the regular polygon of n sides. So, and this one too. And you'll be able to, we'll be doing these problems so you know. N minus 2 times 180 over n. So they figured this out. It took a long process to figure this out, so it's just good to know the formula and you plug it in. The center of a regular polygon is the common center of the inscribed and circumcised circles. So the center is going to be the common center, whether it's a circle or the polygon, you're going to have a center, right? And that's going to be the center of a regular polygon, as well as the circles. The radius of a regular polygon is the radius of the circumscribed circle. So if there's a circle around the outside, the radius is going to be, of the polygon, is going to be that goes to the circumscribed circle. The angle at the center of a regular polygon is the angle between the two radii drawn to the extremities of any side. So basically the angle is going to be, you're going to look at the angle. Let's look at this angle right here. It says angle AOB. So AOB, that's going to be center angle there, or BOC, and that's going to be the center angle. Those are center angles around the center. That's all it says. So, and of course, the radius here, you see where the radius goes to the outside here. The radius is going, so here's a radius going to the polygon here, or the outside. The radius actually goes to the circle, the circumscribed circle. And then we have this, what's called apothem. It's a new word, right? So this word you're going to have to know. Apothem of a regular polygon is the radius of the inscribed circle. Okay? Let's figure this out. So there's a radius that goes to the radius of a circle is going to basically go to the circle, right here. So now we have two circles, the inscribed and the outscribed. So the radius that goes to the outside circle is the radius, right? But now you have the apothem. The apothem just goes to the polygon. Say apothem, to the polygon, right? So it's just going to go to the polygon. So this will be the apothem, and then of course all the way to the end of the circle would be the radius. So just so you know what apothem is, it basically goes to the basically the angle of the center of a regular polygon is, well, this is the angle. So, but anyway, the apothem of a regular polygon is the radius of the inscribed circle. So it goes to the inside circle. This is the angle they're talking about, and this is the apothem. It goes down here. Okay, it's kind of important to know. I circled number 9 here for some reason. It says prove that an angle of a regular polygon is equal to the supplement of its angle at the center. So we're going to need this. So the angle of a regular polygon is going to be equal to the supplement, that's at 180 degrees of the angle at the center. So the angle is going to be supplementary to the angle at the center. So if you have an angle of the polygon, these angles of the polygon right here, so you have a polygon, here's your angle, it's going to be supplementary to the center angle. This angle, supplementary to the center angle. Supplementary means you add them together and they get a what? 180, right? 180 degrees. So that's going to be important. So prove that an exterior angle of a regular polygon is equal to the angle at the center. Okay, exterior angle. The exterior angle is going to be equal to the center angle. So let's look at here. So an exterior angle, so here you have, this is the interior angle right here, and it's going to be supplementary. That means this plus this equal 180. So it's going to be supplementary to this one. But the exterior angle of this, which is on the outside, if I drew lines on the outside, external angle is going to be equal to that angle. So just think exterior is going to be equal to the center angle, just to know those two things. Alrighty. Okay, let's go on with your quiz. Here we go. Quiz 45, pretty short quiz really. So, how many sides will a regular polygon have if its central angle is 40 degrees? So remember how we had to do that? We had it right here. I said you have to remember this. Right here, 360 divided n sides. That's where we can find the sides. So we take 360 divided by 40 degrees, which is 36 divided by 4. Make sure you put your work in this. Equal what? 36 divided by 4 equals 9. So it's going to have 9 sides. See how easy that one was? You just plug in 360 degrees divided by 40 degrees, and it gets 9, and you'll have 9 sides. That's the formula. Number 2, find the measure of an exterior angle of polygon in number 1. So, okay, so we basically have these angles. We have the angle of 40 degrees and 360 degrees. So find the measure. The central angle is equal to the exterior angle. So if we know the central angle is 40, it's going to be equal to the exterior angle. So it's going to be the same. All you have to put is 40 degrees. This is on page 10, page 263, the one I just showed you. In fact, let's look at it again. Exterior angle of a regular polygon is equal to the angle at the center. So now we know that 40 degrees is going to be the same as an exterior angle. Now, if it was just a regular angle, it'd be supplementary to it, okay? Number 3, find the sum of the angles of a regular pentagon. So, how are we going to do this? Remember the formula we have right here. N minus 2 times 180 over n, n being the side. N being that side. So here we have. So the sum of the angles of an interior, find the sum of the angles of a regular pentagon. N equals the side. The sum of the angles is going to be n minus 2 times 180. So they want to find the degree, the sum of the angles. So here we go. We have, there's how many sides in the pentagon? 5. So we have 5 minus 2, plug it in, 5 minus 2 times what? 180. So 5 minus 2 is 3 times 180, which here you can put your work here, we're working it out. 180 times 3 there, and you get 540. So this is going to be 540 degrees. So we just plug that in. On to number 4. Name the line that is drawn from the center of a regular polygon to be, let's see what I have. Find the sum of, which one is that we're at? Let me see. Name the line that is drawn from the center of a regular polygon perpendicular to the sides. So this is on page 263. And what's the name here? Apophthegm. The regular polygon is the radius of the inscribed circle. So here we have a picture of it. Here's going to be a regular polygon that happens to be a square, and the apothem is going to be that line that goes to here, and it goes, the name of the line that's drawn from the center of regular center. So if you had a center circle like this, it's the external circle. That would be the line for the interior circle here. See, like that. That's called the apothem. It's going to be important because we're going to have to find that on a lot of different problems. Apothem. So now this looks like it's a lot of work, but it's not. It's an easy question too. It says find the length of a line in number 4 that is drawn in a regular hexagon that has a radius of 6 inches. Okay, so let's see what we're supposed to do. So here we have a regular hexagon. I drew it here, 6 sides, and here we have the circumscribed. And actually, you could put it inscribed if you want to. But anyway, so we have this little that is drawn. We have this little triangle that makes part of the. Excuse me, I gotta sneeze. Excuse me. Yeah. So anyway, so you take this little part out and you have what? So here we have this line up here is going to be the apothem right here, that little line, apothem. So here we have on this side 6 inches. This is going to be 6 inches on this side, 6 inches on this side. These are the radiuses, remember? 6 inches on this side, and this, if it's regular, is going to be 6 inches. So we have all 3 sides of being 6 there. And so what they want to know is line in number 4, this apothem. They want to know what the apothem is. So I told you we were going to do that. So we have a special triangle here, equilateral triangle. And so to find this apothem, we need to divide it into 2 because we need a right triangle here. So here's a right triangle. See this little one here? This side would be right triangle. A right triangle looking like this. Right there. And it's going to have 6 is going to be the hypotenuse. And of course you're going to divide 6 in half here. Divides it in perpendicular bisector. So we're going to end up having 3 here. And so what they want to know is what this is here. So in the midst of this, we're going to use, because it's a right triangle, we can use a square plus b square equals c square. So a square plus b square is c square. So we're going to take 3, this is going to be a, so 3 square plus b square, we don't know what b square is, but we know what c square is 6. So 3 square plus b square equals 6 square. And so we have 3 square is 9 plus b square, we don't know that yet, plus 36. Well, then we can get rid of this 9 on this side and put it on this side. So 36 minus 9 equals 27. I said 25 at first, so that's why I changed it here, but 27. So we have 27 there. So we have b squared equal 27. So we have b equals the square root of 27. Well, the square root of 27, let's put it here, since you can't read it that good. The square root of 27, I'm going to put here, of course, under here is 9 times 3 is 27. So we can get rid of that 9 because, of course, 3 goes in there, 3 times 3, so we can get rid of the 9. So we say 3, because 9 times 3, times the square root of 3. So apothem in this situation, when you see this, you probably see one with this 6 on each side like that. The apothem is going to be 3 times the square root of 3 inches. Because make sure you always put your unit in there so that we know. So 3 times the square root of 3 inches is the apothem. So you see how we did that? You could always use this. Now we know. Sometimes you don't even have to worry if you know already. You can look at this and say, oh yeah, it's 3 times square root of 3, because this is a very regular triangle that will happen in regular polygons, right? Polygon having any number of sides, but it has to be regular in the midst as a regular polygon if it's inscribed in a circle or circumscribed about it, right? So that's it for this. And we'll go on to the next section.